Sam collected data by measuring the pencils of her classmates. She recorded the length of the painted part of each pencil and its weight. Her data is shown on the graph at right. And so for every one of these pencils, she recorded two properties, right? Both the length of the painted part and the weight. So if I thought about this pencil, the length of the painted part would be from right here to back to the metal part that holds the eraser in place. And then she put it on a scale and she measured not only the length in centimeters, but also got the grams. And I can see this data here. And yeah, let's look at the first question here. It says, describe the association between weight and length of the pencil. Well, it appears that as the length of the painted part gets longer, that means it's a newer pencil, hasn't been sharpened as much, and it weighs more. So that's something I would say that, so as the length of the painted part gets longer, and they never do get longer, right? They actually always get shorter on a particular pencil. But when I'm looking from a collection of pencils, the ones with the longer painted portion tend to have more pencil there and more weight. It says, remember to describe the form. The form largely looks linear, I would say. The direction is increasing, right? As the length of the painted part is increasing, the weight increases. The strength, I would say that it's a strong relationship. These points are pretty well clustered around a line I'm imagining. And there does appear to be an outlier, right? This point doesn't quite look like it fits the rest of the data. It says make a conjecture, a guess about why Sam's data had an outlier. This is my conjecture, not necessarily yours, but this one has not got a lot of painted section yet left, right? It's been sharpened quite a bit, but it could be just it's one of those really big, like fat pencils that they have like in the first grade or something, or maybe it's made out of something other than wood. I don't know. So that's my conjecture. Sam created a line of best fit W equals 1.4, which would be like the y-intercept, plus 0.25L, where W is the weight of the pencil in grams, and L is the length of the painted part of the pencil in centimeters. What does the slope represent in this context? Well, the slope is 0.25, and in this context, it represents the amount that the weight increases as the length of the painted part increases by 1 centimeter. So every single time the length of the weighted part increases by 1 centimeter, this slope in context means that the weight is going to increase by a quarter gram. So if the length of the painted part went up by 4, the weight of the pencil would go up by a full gram. That's that. Sam's teacher had a pencil with 11.5 centimeters of paint. Predict the weight of his teacher's pencil. So here we know that we're given the length of the painted part, right? L. And if I wanted to predict the weight of this pencil using Sam's model, I would write the weight should be 1.4 plus 2, no, not 2.5, plus 0.25 times L, and L in this case is 11.5. So when I plugged that into my calculator, I got that the weight W should be 4.275. And if I look at that on the graph, 11.5, here's 11.5 is about here, and the model is somewhere in this area. So I think Yeah, I'm happy with that answer. It seems like it fits the model anyways. And then finally, interpret the meaning of the y-intercept in context. So for this one, if the y-intercept, well, if the x value was 0, that means there would be no painted part left. So that means that the y-intercept should be the weight of the eraser and I can't remember the name of the little metal part at the end that holds the eraser in place. I think it's like the ferrule, but it would be the weight of that part of the pencil because you've sharpened it all the way down. So it's not 0, there's still something there. Okay, for question 5, we're asked to rewrite each expression without parentheses and use only positive exponents. So let's look at A. In A, I'm multiplying 3 times -2, so that is going to have -6 as part of my answer. I only have a single factor of x, right? This is x to the first power, so I'll just go ahead and write the x. And then I have 3 factors of y. That's y times another factor of y. So I have a total of 4 factors of y. So this would be -6x y to the 4th power. If I look at B, okay, these are parentheses here, but they're not different terms. It's just one thing. And so I'm not creating an area model here. It's not something plus something. It's just multiplication. In this first part, when I look at this x to the 3rd, and I'm multiplying by x to the -2nd, that's just going to be x to the 1st power. So part of my answer will be a single factor of x to the 1st power I can write, or I can leave the 1 off. And then I have y to the 2nd power times y to the -2nd power. That would be y to the 0 power, right? And since that's y to the 0 power, that equals just the number 1. So I would write this one as just plain old x. It's just one single value of x. It's an odd way to write x. See, let's go to question C. C does have this negative exponent. I think first I'm going to deal with the 6/3. So 6/3 does have a common factor. 6 is 2 times 3, and 3 is just 3. So I see that there is a giant 1 there, and I'm left with just the number 2 in the numerator, and then times x to the -2nd over x to the +2nd power. And to clear this negative exponent in the numerator, I'm going to multiply this by x, not 2, by x squared in the top and x squared in my denominator. I keep writing a 2 there. X squared in the denominator. In the numerator, I have this x to the -2nd times x to the 2nd. That is x to the 0 power, and x to the 0 power equals just 1. So my numerator ends up being 2 times 1, or just plain old 2. 2. And the denominator then ends up getting 4 factors of x, right? Because I've got 1, 2 factors of x and 2 more. So 2x to the 4th power. So this is, I'm sorry, 2 over x to the 4th power. Let's say that correctly. And then our last problem is, see, I've got something being raised to the -3rd power, and it's in parentheses. So what I'm going to do is I'm going to clear this first by multiplying both the numerator and denominator by 2x to the +3rd power over -2x to the +3rd power. When I do that, this is going to become a -2x to the -3rd times -2x to the +3rd, which is -2x to the 0 power, which equals 1. So the 1 is the only thing I have in the numerator. Now in my denominator, I have 3 identical factors of this -2x. There's 3 of those. And I know that it's going to be -8x to the 3rd, but let's write it out and see. So if I was going to write it out just to investigate, it's going to be a -2 times an x times another -2 times x times a third -2 times x. So in my denominator, I have this -2 times -2 times -2. 2 of them together makes a +4, and then +4 times another -2 makes -8. And there are three factors of x, 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 so x to the third. So this can be, my final answer would be 1 over negative 8 times x to the third power. Let's move on to question 6. In football, the path that a defender must run to tackle the ball carrier is called the path of pursuit. If the ball carrier runs 40 yards to the end zone and the path of pursuit is 45 yards, how far apart were the ball carrier and the defender when they started? So if we take a look at this, this is the person who's carrying the football right here, and this is the person who's going to chase after that person. And I know two things. First of all, this right angle right here is not an accident. They're definitely indicating that there's a right triangle at play. So I'm immediately thinking of the Pythagorean Theorem, which is actually in this section of the text, and maybe we should review that. But let's go ahead and do the problem first, and then we'll review it. Oh, no, it says even hint, use the Pythagorean Theorem. That's great. And if you need help doing that, refer to the math notes in this very lesson. That's solid advice. I appreciate that. So the Pythagorean Theorem expresses a relationship between the three sides of a right triangle. Two of the sides I call the leg. Those are the ones that are coming out of the right angle. And the third side we call the hypotenuse. So if the ball carrier runs 40 yards to the end zone, so we know that this distance is 40 yards, and we know that the path of pursuit is 45 yards. They're asking me to figure out what this value is, and I'm just going to arbitrarily say that this is x, right? So I'm trying to figure out the length of x. And when I see a problem that involves the Pythagorean theorem, I'm typically talking about legs and hypotenuse. And I know that if I take the leg, a leg squared, and I add to that the other leg squared, in this case x, right? Those are the two sides that are coming out of the right angle. I get the hypotenuse squared. So this is 45 squared. So I do need to square these values. So 40 squared is 1,600 plus x squared, and that equals 45 squared, which is 2,000 and then 25. So from each side of this, I'm going to subtract 1,600. So that's going to give me x squared on the left-hand side. And if I take 2,025 and I subtract from that 1,600, I get that that's 425. Whoops. And then to figure out what x is, I'm going to take the square root of both sides of this equation. And when I do that, I get that x is, actually x could be positive or negative, this value, but it only makes sense in this context for it to be positive. So x is about 20.6 yards away. So this distance between the two runners at the beginning was 20.6, and these were expressed in yards. So every single time I see a Pythagorean theorem problem or I see someone hidden somehow, I'm always thinking about leg squared plus the other leg squared equals the hypotenuse squared. I fill in what I know, and I basically isolate the part I'm trying to find and solve from there. Let's move on. While on vacation with your family, you will be driving from Los Angeles to San Diego. If you take the freeway, it's a distance of 144 miles, and the average freeway speed is 75 miles per hour. If you take the scenic route along the coast, and why wouldn't you, the drive will actually be shorter. It's 122 miles and an average speed of 65 miles per hour, so you are going slower. Which is the better route to take if you want to get to San Diego in the shortest amount of time? Show your work using giant ones. So I'm not quite sure I agree with the the path of using a giant one, but I'm going to try to do that. So if I take the freeway speed, the freeway was a distance of 144 miles. So I'm going to go ahead and start by just writing it's 144 miles, M-I-L-E-S. And I want to multiply that by something so that miles go away. And instead of miles, I'm going to turn that into time because I'm trying to figure out how much time. So what I think I can do is I'm told the speed is 75 miles per 1 hour. So I've got 75 miles per 1 hour. So if I take the reciprocal of that rate, right, I'm going to say in 1 hour, I will travel 75 miles. So when I look at this, I can clearly see that my units of miles over miles cancel, and I'm just left with a time expressed in hours. So when I do the 144 divided by 75, I get 1.92, and my only units left are hours. So I can say if I go the freeway, it's going to take me 1 hour and 92 hundredths of an hour, 1.92 hours. Now, I don't know if I should be talking about converting that into minutes because it's not 1 hour and 92 minutes. It's 1 hour, it's 1.92 hours. And I'm just going to leave that one there for a minute while we talk about if I went the coastal way. If we went the coastal way, we would be traveling a distance of 122 miles. Not aisles, miles. And I'm doing that at the speed of 65 miles per hour. Another way to say that, 65 miles per hour, is that in 1 hour, this is the reciprocal of that rate, in 1 hour, I would travel 65 miles. So I can see here my miles are going to be eliminated with my miles, and I'm left with 122 divided by 65, which is 1.87. Not in pink. Not in pink, not in that. It's going to be 1.87. 1.87. 1.87 hours. And I'm not sure what the textbook did in terms of converting these things to minutes, but I'm going to do it anyways because I do have both trips are an hour long, right? So those are 60 minutes, but I'm going to go ahead and convert this 0.92 and this 0.87 hours into minutes. And because 0.92 is nearly 60 minutes, but let's go ahead and convert each of those into the number of minutes. So to do that, if I've got 0.92 hours, boy, this feels like a reason for using dimensional analysis right here. 0.92 hours, and I want to turn that into minutes. I would say I'm going to put hours in the denominator and minutes in my numerator. Of course, that's not a giant one, but the moment I write 60 minutes is the same thing as 1 hour, it is. And I don't have to do that with both of these. I can see at this point the process for doing it. I just need to take and multiply 0.92 times 60. So 0.92 times 60 is going to give me that this one is 55.2 minutes. So this is 1 hour, and 55.2 minutes. That's great. And the other one is going to be, it's also 1 hour. But I can see what I do. I just need to take the 0.87 and multiply that times 60. And I get that that's going to be 52.2 minutes. So 1 hour and 52.2 minutes. And I'm only saving, it's only 3 minutes difference, right? So it's not significant. And And we know how these things go. You get one extra traffic light, although they did say it was the average speed for the distance, so I don't know. So we are moving on now to question number 8. Question 8 says, solve the equations below by first rewriting each equation in as a simpler equivalent equation, and then we're asked to check our solutions. So on this first one, I'm going to divide everything by 10. If I divide all the parts by 10, right, so you can think about it like this. I'm pushing across a factor of 1/10. So everything's going to get multiplied by 1/10. If I do that, this first thing is going to become 20. So I have 20x plus the number 5, and that will equal 800. If I take away 5 from both sides, that's going to give me that 20x is 795. And if I take 795 and I divide that by 20, I get 39.75. So x is 39.75. And I could check that by just go ahead and I'm going to grab my calculator and just go 200 times 39.75, and I get, yep, I do. I get 7,950, and if I add 50 to that, I get exactly 8,000. So what you heard me do was checking it, right? That was, you heard me checking it. And let's move on to the next one. So this next one, I'm going to push across some factors to eliminate these fractions. And I can see on the left-hand side, there are 2 terms, right? There's 2 terms, 1, 2 terms, and on the right-hand side has 1. But I'm going to push across, I'm going to push 8x across these. So 8x will eliminate all of these fractions. And I know it will because 4 is 2 times 2, but 8 is 2, 2, 2, right? 8's got 3 factors of 2, so 8x will totally do this. I'm not always going to write this step out, but I want to write it here. So this is going to look like I've got 21, but I'm going to be multiplying that by 8x over 4x plus, the next one I've got 9 times 8x over 8, and then that's going to equal 2 times 8x. So what I want to point out is that I put a factor of 8x here, here, and here. Every single one of the terms got brand new shiny factors of 8x. When I do that, this first term, 8 over 4 is going to become 2, right? And x over x is a 1. So this is going to become, it's going to become 2 times 21, which is going to be 42, plus this next one, this is a 1, so this is going to become just 9x, and then that's going to equal on the other side 16x. If I take away 9 from both sides, we're going to get that 42 equals 7x, and isn't that pleasant? That's so nice. When I divide both sides by 7, I get that 6 is apparently what x is. So we've got x is 6. So now that we've got our value of x, I'm going to check that. And I think I'll write down the check here. So this is going to become 21 over 6 times 4 is 24 plus 9 over 8. And that should equal the number 2. Turns out it's not going to be difficult for me to get a 1 here because 3 times 8 is 24. So I'm going to multiply, here's the power of 1. I'm going to multiply, 3 times 8 is 24. Yeah, 3 times 8 is 24 for sure. And 3 times 7 is 21. So I'm going to multiply this fraction only by 3 over 3. And again, I can totally do that. I'm multiplying by 1. It doesn't change its value. It just changes its form. So this problem becomes 21 over 24 plus 9 times 3 is 27 over 24 And if I combine 21 with 27, that's 48. And you know what? It turns out that if I have 48 and I divide it by 24, I get exactly the number 2. So yes, when I plug 6 into that equation, it makes both sides of it equal to 2. So that solution checks. So question 9 says copy and complete the table below, then write an equation for this function. Okay, I'm actually going to start with the equation because I'm a little confused about how we're jumping around here. So I do think because when x is 0, right, when x is 0, I'm getting 3. So it looks like I've got my y-intercept of 3. And why not? Since I'm here, I'm just going to go ahead and use these 2 points to figure out the slope. Well, the points don't go that way, they go the other way. But my change in y, I'm going to go 18 minus 3. I'm slowing myself down and making sure, yes, that really is, those are the y values. And I went the first one minus the second one, so 18 minus 3. And on my denominator, I'm just going to put the number negative 3 minus 0. In my numerator, I've got 18 minus 3 is 15, and in my denominator I have negative 3 minus 0, which is negative 3. That means I'm looking at a slope of negative 5, right? Negative 5. My slope is negative 5. So this equation is y equals negative 5x and then plus the number 3. So I just have to multiply by 5, take the opposite, and then add 3 if I want to fill the table in. So let's go ahead and do that. So negative 5 times 10 is going to be negative 50. And if I add 3 to that, this should be negative 47. Negative 5 times 6 is negative 30. And negative 30 plus 3 should be negative 27. 7 times negative 5 is negative 35. Negative 35 plus 3 would be negative 32. Negative 5 times negative 10 would be 50, plus 3 would be 53. Negative 5 times 100 is negative 500, plus 3 is negative 497. 7. And then this is it says then x is right here. So x would be, if x goes in, then that should be the opposite of 5x, and then plus the number 3. All right, that's it.